Hello all. In this video we are going to start learning a little bit about actual Python programming. So we will start where your reading leaves off with the print statement, but we're also going to talk about a couple of basic data types that Python has and some simple things we can do with them, including assigning data to variables and doing some basic sorts of arithmetic. We'll learn a lot more about these data types down the line, but for now we're just going to dip a toe in and focus actually on debugging in our activity. All right, so here you can see that what's left of the notes for today, which is about values and data types. So I said before, programming languages have to have data, different kinds of data, and they have to have operations that work on that data. The three most basic data types that Python provides are integers, floating points, and strings. Integers and floating points, those are both numbers. They correspond to integers and reals in mathematics, but we often call them floating point numbers because they're more restricted than the real numbers in math really are. Everything inside the computer has to be finite in size. That means we cannot, for instance, precisely represent all of pi because pi does not ever end. And so floating point numbers are limited. They only have so many digits they can represent. So we have two different kinds of numbers, integers and floating point numbers. And while they're both numbers and we use the same arithmetic operations on them, they are actually represented differently inside the computer. So we make them distinct. An integer is written with no decimal point, and it has no commas. We don't put commas or decimal points or anything like that into the number. They can be positive or negative, and in Python, they can be any size you want. We're not going to worry about limiting the sizes of integers. Integers in Python can have as many digits as you want them to have, but they cannot have a decimal point. If you put a decimal point into a number, it is a floating point number. That's a different representation. But again, positive or negative, we have a form of scientific notation, which you can see here on the page, 6.4e negative 5. That means scientific notation 6.4 times 10 to the negative fifth. So we can represent lots of different numbers this way with floating points. Strings are a different kind of data. They're basically text. In order for the computer to be able to tell when we want text to be reproduced precisely exactly as it is written, we have to put quotation marks around it. So you can see here I put quotation marks around the word hello because I want the computer to know that what I mean is HELLO and not anything else that I might mean. And here I can do a whole sentence inside quotation marks. In Python, you can put anything, meaningful or not, inside quotation marks, and you are both allowed to use single quotation marks or double quotation marks as long as the one at the beginning and the end match. That turns out to be kind of handy. It's just the way Python does things. You do want to watch out if you're ever copying and pasting from a document into Python. The normal quotation mark, like I wrote here, is not the same as this quotation mark. They are different symbols to the computer, and so you have to be careful that when you paste a quotation mark, you actually get the simple one. Sometimes easier just to type it. We can convert between the different data types. We'll talk more about this next time, but you can in fact take in a floating point number and turn it into a string. You can take a string that looks like a number and convert it to an integer or a float, and vice versa. So we can convert between all of these types fairly easily if we have the wrong kind of data for what we need to do. So for right now, we're really just going to focus on the print statement and on arithmetic on numbers, and we'll get back to strings later with a few more operations. So this is the sort of the traditional beginning program that you write is called hello world, and it's just to output the words hello world. I said hello all here because that's what I tend to say at the beginnings of these videos. So you say the word print, and then you have to have an open parenthesis, and then you can put a string inside here. Oops, don't do that. You can put a string inside and you have a closed parenthesis. This is an example of a function in Python, a built-in function, and when you run it, it causes this message to print. So if I run this, then you can see that it says down below in the output panel, I can make the output panel a little bit bigger. It says hello all. Print is a nice function. It's very flexible. You can do lots of things with it. You can print multiple values. So suppose I had a bunch of numbers I wanted to print. 45, 93, 21.2, put a floating point number in there, -7, 101. I can just put them inside the parentheses for the print function and separate them with commas. And print will print them all. It will print them and leave a space in between. So I'm going to run this code again just to show you the result. There you see the output, the values with spaces in between. So you can put as many different kinds of data in a print statement as you want. So I could say print, I think I had this kind of example before, 3 times 12 equals, and then I could put a little arithmetic expression over here. So this, you can see there's a comma here. That's telling us that there are two values that we want to print. The first value to be printed has quotes around it, so that will appear exactly as it's shown. And then the second value does not have quotes around it, so it's an arithmetic expression. That will be evaluated and the value will be inserted. So it'll do 3 times 12 and then put that result into what's printed. So here, this is because of the string, and then this is because of the expression at the end that's highlighted up above. So print is nice. It's very handy. It's for doing output. That's one of those 5 important categories that we said we needed in the earlier video. What else can we do? Well, we can do arithmetic. I mentioned I like to use Python as my calculator because I think it's just more useful than a typical calculator. So if we want to do calculations, you can just put in an expression with a whole bunch of numbers. So I could say 3 times 2 plus 4 times 8 minus 10 divided by 2. Python will evaluate that. If I just put this in a code file and I run the code file, I don't see anything because I didn't tell it to print anything. When you run a code file, you only see the values you explicitly print. So I would have to say print this thing. And then when I run it, I'll see the value 33. It does 33.0 because I did ordinary division here, which always converts the result to floating point. If you're in the console, so if I come over here, I'm looking at the run panel right now. If I go down here to Python console, I could type that same thing in. 3 times 2 plus 4 times 8 minus 10 divided by 2. And I got 37. Was that wrong? Did I do something different? 3 times 2. Oh, yeah, I did. Up arrow in the console will bring you back. I did 9, not 8. There you go. The way to interpret this, by the way, there are rules for priority. Multiplication you do first, and then division, multiplication and division, and then you do addition and subtraction. So the expression that I typed with no parentheses is the equivalent of this one that I've just typed, which you can verify if you run it yourself. You put parentheses in, sometimes you have to, but sometimes it's just for clarity if it helps. All right, but right now this gets kind of tedious. I've got a lot of numbers. Suppose I wanted to do some sort of like mathematical formula like 3x squared plus 2x minus 1, and I want to be able to try that on different values of x. I kind of want to be able to have x, a place where I'm storing a number. So you can do that in Python with a variable. So a variable is a name. It has to contain basically letters, numbers, and the underscore. And I don't think it'll let you start one of these names with a number, don't do it. It's very bad form. Start with letters. You can add numbers if you need to. You can use underscores if it makes sense to you. I'm just going to use X here. So X is a variable. You don't declare variables in Python. You just give them their first values. So I'm going to say X equals 5. After that line, I can refer to X. So I could say print X, and it'll print it. I could say print 3 times X. So you see that notice that it said the value of X is 5, and then it did 3 times X, which is 75. Now I can write a whole Boolean expression. That was doing 3x squared. There's another way to do a square, which is 2 stars. There. So right here I have an description of a polynomial, 3x squared plus 5x minus 1. And if I run it, it'll print that. And then I can change this to be 7. Run it again, and it automatically runs it with the new value of x. One thing to know about variables is that unlike in mathematics, the variable is not fixed for all time. If I say x equals 7, I'm not stating a canonical truth of the world. I'm saying for right now, x holds the value 7. So if I do x equals 7, print x, and then I say x equals 2, there's no logical issue with that in programming. I'm just changing my mind about what x should be. So up here, x equals 7, it printed the value 7, then I changed the value of x to be 2, and that's what I actually used to calculate the last one. So a variable is a container. You put data into it, and then you can change it at any time or update it. So I can say something like x equals x plus 2, print x, and then 3 times x squared plus 5 times x minus 1. All right, so it printed the value 7, and then it calculated the polynomial for the value of x being 2. And then here I said update x. So it looked up the old value of x, which was 2, and it added 2 to it and got 4, and it saved that back into the x location. So you can see here 4 is printed as the value of x, and 67 is what happens if you compute that polynomial for a value of 4. All right, this is really all you need for this first activity. You need to be able to do a little bit of arithmetic. You need to be able to assign data to variables. I can have as many variables as I want in my program. We tend to give them long and meaningful names when they're not just numbers. And so you'll see that when you get into the activity, and you can talk about it more there. This is enough to get you started with Python, get your feet wet a little bit, and then we'll learn a lot more about operations on numbers and strings in our next reading and our next activity. So I'll see you in the next time.